Hello, this is Mr. McGovern and welcome to the first video on the series of energy and work in level 2 physics. So we're going to ask what is energy in this question, in this video. We're going to be looking at a concept called the conservation of energy, and we'll look at the different types of energy. So first of all, what is energy? Well, we don't know. And that's just not a cop-out from me. If you ask any teacher or any physicist in the world what actually is energy, they'll all answer the same way, that we just don't know what it is. What we do know about energy is how it can be useful. And the way it's useful is through a law called the conservation of energy. And basically this says that the total energy in the whole universe is unchanged after we have any interactions. Or another way that you might have seen this is that the total energy before is equal to the total energy afterwards. And that's really important, that we only care about the before and after. And we're going to look at some specific examples, but often interactions can get complicated in the middle, in the in-between. And the great thing about energy is it only cares about the before and the after. And so that can allow us to ignore some complicated in-between interactions. Now, examples, what do you mean by this? The first example is something sliding down a curved ramp. Now, up until this point, we can deal with things sliding down ramps. They accelerate. The issue with the curved ramp is the normal force, which is always perpendicular to the surface, changes because the direction of the surface changes. And so we end up having a total force that changes everywhere down that ramp. We haven't had to deal with situations where the force changes like this before. And so that's a very complicated situation to deal with. And it makes it really easy just to look at position A and position B in terms of energy. We don't have to worry about all the in-betweens. Springs are another idea. I'm going to do a video, in fact I'll do the next video about springs. Springs have a different force no matter depending on how compressed it is. And so that ends up making it a complicated situation. If you want to look at this ball being shot from the spring, we have to consider the spring uncompressing itself, and as it uncompresses itself, there's a different force on the ball every millimeter. So it makes it really complicated. The good thing is we can deal with it with energy. We can just look at the ball being compressed and then the ball having left the spring. The types of energy we look at this year, there's two types: energy stores and energy transfers. The stores you would have come across before in year 11, kinetic energy, which is the energy of movement; gravitational energy, which is the energy stored in a gravitational field between two objects; elastic energy is energy of things being compressed or stretched, such as with a spring or elastic band; chemical energy, we talk about energy in food; thermal energy is what you may have called heat, but you can see heat's in the other column there. So energy transfers is energy being transferred from one system to another, and the way we can do that is work and heat. These will make a lot more sense when we go through specific examples when we do our energy bar charts in upcoming videos.